Hello everyone, and welcome to another ASTOM session where we're going to be covering Oracle Spatial Technologies. In today's session, we will be going over how to integrate Oracle Spatial with open source GIS tools. Our presenter today is Karine. Thank you very much for putting this session together. And we'll be providing all of the links in additional information under the recording. So if you haven't been able to attend any of the previous Ask Tom sessions and you're curious of what you've missed, you can check those sessions under the Ask Tom sessions or Ask Tom website. There is a filter on the side where you can just select the spatial for ADBs, analysts, and developers office hours, and you'll get all of the previous sessions recorded. Feel free to add any questions you have during the session in the Q&A box. And I think we'll have Hans taking care of those questions today. So thank you, Hans, for taking care of those questions. This is a quick disclaimer. Next slide, please. So all of the data used in this year's sessions will be found on the Karine's GitHub repository. If you want to go ahead and try any of those demonstrations or anything, all of that information is there. There are a couple of files that are not available, but we will provide links to those files. So here's a quick reminder. You can also build a geospatial platform using the autonomous database, and I will go ahead and provide that link in the chat for you to have access to that information. So today, Karine will be covering 4 tools that can be used with Oracle Spatial that is part of the database, the Oracle database. And the 4 tools are GDAL, QGIS, GeoServer, and LAStools. So with that quick intro, let's go ahead and pass it on to Karine.
Okay, thanks a lot, Ramu.
Of course.
Yeah, I put this session together since I know that there are a lot of open source tools out there, and people we typically talk to are used to also use open source GIS tools. And in today's session, I actually want to give you some information about those tools and how they can be used in conjunction with the Oracle database, and where there are some kind of tips and tricks you can use to work with the tools together with Oracle Spatial. Those information I have also included in the presentation. I have also prepared some demo parts, more demo parts than we did last time, because I knew that I will be doing this session today, where I'm going to use some of these data sets I presented last time in January. So bear with me that I didn't do more technical parts in the last session. So today I've prepared plenty of demo parts. Okay. I checked the recent surveys about open source GIS tools and how they are used, and I came up with kind of list of different tools and for different purposes. So there are tools focusing on publishing Geo Web Services. There are tools focusing on loading and transforming data, spatial data, or there are desktop tools where you can do plenty of things, creating layers, putting your maps together. So these, what you can see here on this slide is actually an extraction of the different tools. And I will be focusing today on, Ramu said it already, on GDAL, QGIS, LAStools, and GeoServer. I've also checked in preparation of this session today, I've checked more tools. I left them out because either there are missing current information about how they integrate with the Oracle database, or the integration didn't work as expected. So these 4 tools I'm going to focus on today. But of course, if you have questions that are related to other tools, just give us a shout. We are going to check those and see how we can provide you the information you're looking for. Okay, so let's start with talking about loading raster and vector data via GDAL, and GDAL in conjunction with Oracle Spatial typically means that we use GDAL to load spatial data, be it vector data or raster data. But before I'm going to show that, just let me highlight a few things about GDAL. So GDAL is a translator library which you can use for many different formats of raster and vector data, and it's open source. You have a variety of very useful command line tools you can use to load data, to translate data, and also to process data. In today's session, I'm going to focus on the data load, because especially when it also comes to raster data, a lot of what GDAL can do in terms of processing or translation, we can use the in-database functions that are provided to work with vector and raster data and for the processing of the data. So some of the programs GDAL provides to work with vector data, one is OGR Info, and OGR to OGR is the tool you can use to load, for example, vector data into the Oracle database. When it comes to raster data, you can use GDAL Info, GDAL_translate, or tools like GDAL Build VRT, or GDAL to XYZ to extract XYZ data from raster data. So these are the tools you can use. There are many more. I'm going to show 2 of those tools, or I'm going to use 2 of these commands later on in my demo part. So a few things you need to know about how you can use GDAL in conjunction with Oracle Spatial. So GDAL comes with Oracle Spatial drivers, and we published a doc, my Oracle support note with the document ID you can find here, which contains information about which build we provide for GDAL that already includes the Oracle Spatial driver, and also for which platforms you can download those. Typically, when it comes to GDAL, we have only supported, or GDAL only supports Linux and Microsoft Windows. So you have the option to use GDAL pre-integrated with the Oracle plugins. You can also download GDAL on your own and then later on install the Oracle plugins, which you just follow, where you just follow the documentation. What you need for this, if you install it on your own, you need an Oracle Instant Client installed on the machine where you have GDAL up and running. And this is also what I'm going to use later on. I've set up a compute machine on the Oracle Cloud where I have the GDAL package together with the Oracle plugins and the Oracle Instant Client. As for the configuration, you actually don't need to do much things. You need to set environment variables and you need to link libraries. And one of the things you need to do is when it comes to the libraries, you can check whether there are any missing links to libraries with this statement, LDD GDAL home lib GDAL.so. If everything is properly installed, then you can just run GDAL -- version, and you will see the GDAL version displayed. And if there is anything missing, you will get information about which of the libraries is probably not properly linked. There are a few prerequisites, especially when it comes to using raster data or loading raster data into the Oracle database and working with raster data. So you need to make sure that the user who creates raster data and wants to use the raster data has to have trigger permissions in for the database. And this you can actually assign with a privileged user. So probably as a developer, you need to talk to your DBA to get this permission granted. But once you have it granted, you can go yourself log into the Oracle database and with your own user and just execute this call enable GeoRaster once. And if that's executed, then your database schema is prepared to also work with raster data. The raster data support is per schema level, and it's not enabled per default, so you need to enable it if you want to use it to also store and work with raster data. For the part here on the left side, similar to what I've done in preparation to this session today with my Oracle Compute instance, we are going to provide Oracle Live Labs workshop where we explain how you can set up this kind of machine with GDAL installed, with the Oracle drivers in place, the configuration in place, and also the Oracle Instant Client up and running. So please stay tuned. We will provide the information when the workshop is live. Okay, so let's have a look at how we can use the GDAL command line tools in order to load vector data and raster data. Let's start first with vector data. So you have this OGR to OGR command, which you can use to load vector data from different formats into the Oracle database. And the OCI parameter here and the OCI prefix in front of the connection details indicate that this is going to load data into the Oracle database. And of course, you need to provide the connection details. And along with the connection details, you have several options to provide information about how to load the data. You can define the table name where the data should be stored. You can also give information about the dimensionality of the data, the coordinate system of the data, which you need to define the column in the table that will store the spatial data. You can also define whether you want to have the spatial index created along with the load or not. Typically, I would say no here because it's a good practice to, before creating the spatial index, that you validate the data and see whether they are properly set up. Together with the load, the spatial metadata are also created, and you have other information or other parameters which you can play with and see how you can make use of those, like the override or a layer G type parameter. And once you start the command, then you will see the output is down here. So in this case, I'm uploading shapefile. It's a very large shapefile. You won't find it in the GitHub repository Ramu just mentioned, but it can be downloaded from the internet and uploaded using GDAL. And even though it's a very large data set, the loading takes a couple of seconds, nothing more. So typically this you can use the command to create the spatial index automatically if it's not disabled. The metadata are also automatically added. And if there are some things, additional things you should watch and take into consideration, just check the QGIS page. There are some additional notes how to treat the data. So much for vector data. So one thing I actually detected, or I've seen when I loaded some data, was that there were X or coordinate values with a lot or many decimals. And this could be a problem when loading those data using GDAL, and it will give you an error message telling you that the value is the decimal value is larger than the specified precision that is allowed to load the data. And if that's the case, then just use this precision no parameter, and then you get the data set loaded. And as I said before, I typically recommend to validate any data set you load into the Oracle database to make sure that you have valid geometries. We just recently got the message from one of our customers that they detected different results when doing some kind of spatial analysis, and it turned out that the data was not valid. And once they validated or they fixed the geometry, the results were actually as expected. So it makes a difference having valid data. Let's talk about raster data. Raster data you typically load into the Oracle database using GDA_translate. And here you have this parameter GeoRaster, which indicates that this is going to be loaded into the Oracle database as a GeoRaster object. And you specify the file name. You again have this prefix GeoR or GeoRaster, where you define your connection details for the Oracle database. You define the table you want to use to store the raster data, and the column that will be the GeoRaster object. And you can also define an insert statement that is actually a blueprint how you will be loading the data. And if you are a little bit familiar with working with raster data in the Oracle database, you know that before creating an object, a GeoRaster object, you need to have this SDO GeoRaster init call that creates the structures to actually store the raster blocks. And this is something you need to specify here as well. And again, there are additional parameters you can define. So to do a blocking during load, you can also already generate pyramids during the load, which according to the documentation interferes with the way how QGIS can handle raster files. So QGIS actually recommends that you generate the pyramids afterwards, not during the load using GDAL translate. And once you run this statement, you again see how the data is loaded, and you get some output there. And once you have the data loaded into the Oracle database, you can use GDAL info to directly connect to the database, check the raster image, the raster table and the raster data, and you get information about the raster data stored in the Oracle database. So by the same GDAL info call. Okay, so let me just jump to the, oops, sorry. Okay, so I've prepared a few scripts you can find in the GitHub repository. So actually, let me just briefly show you the part of it. So here I have a tiny shell script, which I'm going to use in order to check the shapefiles I have available here and get some information about those shapefiles by using OGR info. Now let's do this. So you can see here that actually I've included this tree command here to see that you have I have some data files here, mixed JSON, vector and raster data. And here are the shape files I'm going to upload later on. So, and this is the information about the different shape files. So what you can see here is the layer name with the and some metadata and what geometry type and different information that tell you what kind of data set it is and how it looks like. And the same we can do for raster data. So I'm actually getting information about some of the raster, the TIFF files. And here you see the information about some of the data set. I'm also mentioned in my previous session about open spatial data. It's taken from the, it's now need to, I don't remember exactly the exact name. Hans, you can probably help me out. But again, that's what you can see with raster data. And let's check now what we can do in terms of loading data. So this is the script to load the TIFF files we've just seen before. And it's again just a shell script in order to avoid running GDAL translate step by step for each of the files. So yeah, putting it into a loop. And then here we have the parameters GDAL translate. The output format is GeoRaster. The TIFF file, and then again my connection details, which I've stored in environment variables. And here is here are the additional parameters I'm going to use to load the raster data. And let's see the same thing for the shape files. So this is what you've seen before, again, put into a loop. So we can load all the shape files at once. And let's start with the shape files. They should actually be pretty fast, even though we have some tables to be filled with shape or geometry data. So this looks fine now, and let's check my database. So here, this is what I did before. I cleaned up this schema, and now we can just see that all these shapefiles have been imported. Once, if the table is not already there, then it's getting created upon upload using GDAL. So this is the part for vector data, and let's do the same for raster data. Okay, so we have now uploaded the raster data, and just let me show you. Here we have uploaded 2 images. And since I told you before that we have this raster table with the SD GeoRaster object, and then a raster data table that is associated to the rasters table, which keeps the actual raster image blocks. And what you can see here is, since I haven't, I've uploaded the data without creating pyramids, all the different blocks are on the pyramid level 0. Okay, I'm sorry. Let me just go back to John. I think I have too many windows open. Okay, now I have it. Okay, perfect. So I mentioned already that we recommend checking whether your data are valid. These two scripts you can use to check the validity of your geometries, and if there are any problems with it, then you just use the second script to fix those. I'm not sure why completion doesn't work. Oh, it's probably okay. I'm sorry. It's a SQL command that I can't do. Okay, let's do it differently. So everything I mentioned, that we have everything here as well. So let's check the geometries. And let's just run it. So it's going through all the geometry tables and checking whether there are any invalid geometries. And what you can see here is the result of it. We have already seen that there is a geometry errors table, which has now all the invalid geometries stored. So information about which of the geometries are invalid. And you can just run that second statement here, fix geometry, to fix those and empty the table. So let's run this as well. Okay. If you do that, and if you have lots of geometry tables with a lot of vector data, then it might be useful to do it in parallel, or to somehow divide running through those kind of checks in order to avoid too long running scripts, so it might be useful to just split the processing here a little bit. Okay, now we have made sure that we have all the vector data valid, and since we also have created or uploaded raster data, we can now use the in-database processing of raster data and actually create raster or pyramids for the raster. And this is something you can do easily by running this little bit of POSQL code, which is also nicely documented and described in the documentation. And but I'm going to run this, and the result of it would be that we have now not only a pyramid level 0, but also pyramid levels 1, 3, 2, and depending on the size of the original data, more pyramid levels. So this is something you can do using GDAL, but you can do it in the database directly as well. Okay. Good. So much for GDAL. If there are any questions, just let us know and we can get back to it and provide you with more information if needed. So I'm just included a few of the slides, so you just have the information. So maybe one word about this image here. Together with the Oracle database, especially exactly if you install the database examples, you will find in the home for spatial, which is Oracle Home/MD, you will find a demo folder that contains a tiny set of different tools, and among those tools is a GeoRaster tool, which you can use to load raster data, to visualize raster data, get information about raster data. And this is what I've done here. The raster data I've imported into the Oracle database, I've just visualized using that tool. Okay. So much for GDAL. Let's go ahead with QGIS. So QGIS is a very popular desktop application which you can use to create, edit, visualize, analyze, and also to publish geospatial information. Plenty of different spatial data vectored among those vector data, raster data. You can create vector tiles. It can work with 3D tiles or 3D data, point clouds. And the important thing about QGIS here it is that it works with the Oracle Instant Client, and there are drivers that you can use to plug those, or if there are plugins you can use in conjunction with QGIS to actually also work with GeoRaster. GeoRaster is not supported by default or integrated by default in QGIS. There is a plugin for it, and which you can download and install in QGIS. So this GeoRaster plugin was built and written by an Oracle partner, Oscars in Belgium. Unfortunately, Oscars no longer exist. I have no current information about how this GeoRaster plugin will be maintained in the future, but that's something we can follow up. We have only recently known that Oscars does not exist any longer as a company, so we need to check this. Okay. So what's important? If you want to work with the Oracle database, you need to set up the database connection. We have seen this before on the command line. We provided the connection details via these environment variables. And here we have a graphical user interface where we can define the connection name and which database we want to connect and host and port information, and also different parameters which you can define, how QGIS actually fetches information from the Oracle database about the spatial data stored in there, or whether you also want to have listed tables that do not contain any spatial data, so also list tables with no geometry. Right now here is such a parameter or a checkbox. So this is pretty straightforward, nothing special, other than you might know it from SQL Developer, for instance. And you can see here it works for a database 19C, and I've also tested an Oracle database 23C. And what's probably a little bit different or something to specifically be aware of is how you connect to an autonomous database. Autonomous databases, typically you connect to those using a wallet, but there's also wallet-less connection which you can define, and this is a wallet-less connection to an autonomous database specified here via these parameters. And the important thing here is that you need to define as host TCPS, and then you have the domain for the Oracle autonomous databases in the Oracle Cloud. It might be in a different region depending on where you have the autonomous database up and running. And here for the database, you have the service name for the autonomous database specified. There is a blog post I wrote last year, which explains this in details. So I'm not going over this in more details. Just check it out and set the connection up if you have an autonomous database. Okay, let's actually do it before we. So let me check. Open QGIS. So fix. Okay. So I'm going to open this project, and here you have the connections. And there is Oracle, which is only available if you have the plugins installed. And it takes a little while. So here I have my connections, and I'm going to use this connection here for the Ask Tom session. There is a spatial user, and now we can see all the different tables I've previously loaded, and I've also already added those to my current project. And you can add vector data layers like you want from those you have stored in the Oracle database. So this is just an example of some of the data I have uploaded previously. Let's go ahead with GeoServer. GeoServer is also widely used, especially when it comes to publishing spatial data. And it's typically provided as a web archive you can deploy on an application server. There's also Windows installer if you want to run it on Windows. I've again taken the web archive and deployed a Tomcat application server on an OCI compute instance, and deployed also GeoServer on that Tomcat application server. And the Oracle support is available via a plugin, and here you can see how you can get the plugin and how you actually install the plugin. It's nothing more than going to the Catalina home, your Tomcat home, under Web Apps, GeoServer, and WebInf, and add actually the libraries into that folder. And the current support, as far as I've seen, for GeoServer is for vector data only in the Oracle database. So maybe going a little bit into more details. I've prepared a description of how to deploy GeoServer on Tomcat 9 to set up the Tomcat or the compute instance with installing Tomcat, installing Java, and then deploying GeoServer on Tomcat. So you will find this GeoServer deployment markdown file in my GitHub repository, and I've explained how you can do everything in details here, configuring the Tomcat users, open the ports you want to in order to make sure that you can access the application, then also installing the JDBC driver in order to be able to set up a JNDI connection to your Oracle database. So you need to define a data source as a JNDI data source, and this is how you can do it for Tomcat. And then you start up Tomcat again and start run GeoServer. And this is what you at the end come up with. So here's GeoServer up and running. And what you then need to do is, once you have the data source created, then you are able to first create a workspace, which is, okay. Once written correctly, everything works fine. So the first step is you need to define a workspace, which I've done here. So it's my current and default workspace Oracle. And then you go ahead and create stores for that workspace. So my store is actually my data source I'm pointing to with a store name. And then once you have that in place, you can define layers, which are actually geometry tables or subsets of geometry tables. And here you can add new layers by using your data source. And then you can see here that you get a list of all the spatial tables in that database, and then you can go ahead and publish those. And I've did it already for those two tables, US counties and US grid. And let me check. I think you can also use this to preview the data, which I'm going to show you right now. Here with a few screenshots. So this is the workspace I've set up, the store, the data store. Then I've published some of the data sets, which are called layers. Oops, sorry. Then I have the possibility to preview a layer, and you can select the format you want to have the layer displayed here, and I've chosen one of the available layers, which is an open layer format, which you can use here with the typical mapping features. Okay, so GeoServer you can use to publish your data sets in the Oracle database, create web services, or publish your data sets as web services, or use it in different ways you want to use GeoServer for. And the last but not the least of the tools I want to talk about is LAStools. LAStools here is focusing on LiDAR data, or also called point clouds. And this is why I've chosen LAStools, because it takes a different type of data sets and focuses on processing these types of spatial data. LAStools, if you check the website, you can see that it's actually a tool set, also command line based, which you can use, where you can use the different commands to do different things. And what I've done actually is that I've taken original LAS files and converted those into text files. So those text files then are human readable and easy to parse. And since everything that's human readable and easy to parse, like text-based information, you can easily load into the Oracle database using the SQL loader or using SQL CL, or for the autonomous database, there is a data load tool you can use. You can use SQL Developer. That's easy, and this is why I've chosen to convert the LAS files first into text files and then load those text files into the Oracle database. And this is what I'm going to show you right now as well. This time I'm going to use a different Oracle database version, because we have some new features for point clouds or LiDAR data in the Oracle database with the Oracle database 23C, and I've reused some scripts I've already worked with for a presentation on Oracle database 23C. Okay, so let me check the I do have the, okay, here we go. Okay. So working with LiDAR data or LAS files, and what you can see here is that we are going to use the LAStools to get some information. And here I've downloaded a data set which you can download yourself from the internet, and I have the link included somewhere, I think, in the presentation. And from there, you can extract the LAS or convert the LAS files into text. And these are the parameters. So for parse, you specify which of the parameters inside a LAS file you want to take over into your database table, or I'm sorry, want to extract and put them in the text file, and you also specify the delimiter you want to use. And once you have done this, you can switch to your Oracle database and start working there with SQL. And this is what I'm going to do right now. So I've already. Let me switch things here a little bit to actually copy and paste from my script. So here you can see I'm connected to an Oracle database. Let me take the script down here. So I'm dropping the table, recreating the table, and these are the database, the table columns matching the parameters I've specified in the parsing as being parsed and extracted and into the text file, and then I do something else. I actually create a view for that table, which I'm going to later work on. And what I'm going to do right now is that we will be taking the text files and storing the text files as point cloud objects into the Oracle database. And for that, we create a new table called LiDAR scenes, and a little bit similar to what you have seen in the raster. For raster data, we have an additional table structure coming along with the point cloud objects, where we store the blocks for the point clouds. And now we can use SQL loader, SQL CL to load the data. And here we just define a few parameters. And now let's do the actual load. So I've cleaned up the table, the input table. Then we can use SQL loader, SQL CL, I'm sorry, and the load command in SQL CL to load the text file and the content of the text file into the LiDAR input table, which has this very flat structure, which we can later on use to create the actual point cloud objects from those LiDAR text data. Okay, maybe I'm going to take the script and just explain the rest. I want to go through with you. So let's go from here. So what I've done here is I've taken the text data and loaded those into this flat table structure. And from there, we can actually create the point cloud objects and put those into the table LiDAR scenes. So here again, similar to what you know from GeoRaster, we initiate the creation of the object and then load the data into that object. And here are the parameters we are going to use. What you can see here is, since we have this block table along with the actual SDO point cloud table, we can define the capacity, how many records from that text file, meaning how many points will be part of one block for the point clouds. And this is the statement you see here. And then we create the actual point cloud. This is why I've defined this additional view, which has a specific structure. And from that specific structure, we can create the point cloud and then commit everything. And then I would have loaded the second LiDAR data set, which is the same area but one was before a hurricane, and the other LiDAR data set was taken after a hurricane. And what we can, with the Oracle database 23C, is we can compare those two LiDAR data sets and create a difference data set. So this is one of the new features of the Oracle database 23C, creating difference point clouds of two original point clouds. And this is what I've described here in this working with LiDAR data. So you take the LAStools, convert the original LAS files into text file, then load the text file into the Oracle database with a tool of your choice, and then you create the actual point cloud objects, which you can then use with the different functions you have there in the database to work with point clouds. Okay, so here you see that there is the point cloud data set uploaded with 2.5 million points. I'm going to leave the rest out since we are already at the top of the hour. So let me go back to the presentation and finish. Here you see it and more details, the different steps I've done, and the rest is everything you can find in the scripts in the GitHub repository. Okay, so I could have included more tools, but it's only an hour, so not much time. Yeah, feel free to reach out to us if you have any specific questions which we couldn't cover today. You can also use those resources, and maybe it's time to hand over to Ramu again for the rest of the slides, which are not that many. Thank you, Ramu.
Thank you, Karine. Great job. Thank you for that session. So here we have a couple of links where you can get some information. Oracle Live Labs is a great place for you to get started with spatial if you want to go ahead and take a stab at, demos where you can just do it on your own time. It's a perfect place. We also have a link to documentation, reference architecture. We do have vlogs on how-tos for Oracle Spatial, as well as a YouTube channel that we use to announce new stuff coming into Oracle Spatial, and our LinkedIn group. So if you want to stay updated with any news, the LinkedIn group is a great place to start. Next slide, please. I've gone ahead and also included these links in the chat in case you have any additional questions. You can just post them in the Oracle forums or Stack Overflows. We do check those constantly. So a great place to ask questions. And I think we don't have time for additional questions, but if you do have more questions, definitely use the forum on the Stack Overflow. So let's go to the next slide, please. So our next session for Ask Tom is March the 26th, and we will be going over Spatial Studio and Oracle Analytics. Things might change, but as of right now, that's the plan. And last slide, please. Also, if you have any other additional questions about this session, here is Karine's email, or you can also tell her how well she did in this presentation. Thank you very much for watching, and I hope you have an awesome day.